we have discussed the creation of horizontal alignments, longitudinal design and super elevation design. Now we can move on to the cross-section design. This module includes how to create and modify cross-sections for roadbeds, side slopes, and side ditches. Firstly, we will discuss the creation of the roadbed template. There are two types of roadbed templates: highway and urban road. The type of road influences the default template types. If the road class is highway, under the section and modeling module, in the roadbed template and slope template tool, click the Create Highway Roadbed Template button. Select the alignment and select the drawing base point to open the Create Roadbed Template wizard. Or, you can click the Create Roadbed Template icon. In the Edit Alignment window, select the base point. The Create Roadbed Template wizard will also be opened. You can set the highway class and the design speed at the top. The right side of the window shows the road widening standard. Here, you can select the standard that is most suitable for your conditions. The left part is the roadbed parameters. Here are different types of roadbed elements, such as median strip, driving lane, hard, and soft shoulders. You can enter the width of these elements, and the roadbed width field will show the total width. You only need to enter the width of the common section in this window. After the setting, click OK to continue. This window is the Create Roadbed Template window. You can select each component and edit the parameter on the right side. The width expression under the part width field controls the width of the component. For driving lanes, if the standard width of one lane is 3.5 meters, the width expression is 3.5. If you want to set 2 lanes, you can enter 2 times 3.5. You can also set unequal lane widths for some unusual situations. For example, if the driving lane contains 2 standard 3.5 meter lanes and a 3.75 meter wide lane, you can enter 2 times 3.5 plus 3.75 to achieve that. With this method, you do not need to calculate the total width of driving lanes. You may notice that there is a plus $JK behind the number. It is the intelligent widening function. With this mark, the system will automatically calculate the widening value and transition section length for the alignment when we draw the route offset curves and build the model. Below that field, you can select the widening method. EICAD supports linear, quadratic, cubic, and quartic in a total of 4 methods. Finally, EICAD supports the widening data table. You can enter the station and the widening value. The system will search for the station number of each turn. You can enter each value or import a CSV file. On top of the template, you can insert and delete roadbed components. For example, if we want to insert a side strip, select the driving lane and select the Insert Side Strip. In this window, you can select where to locate the side strip. Select Yes to locate on the road's inner side, and select No to locate on the road's outer side. When you finish editing one side of the road, you can click the Mirror Roadbed Parts button to apply the modification to the other side of the road. When you finish the modification, and click OK to generate the cross-section. If the cross-section is too small, you can double-click the cross-section entity to open the Edit Roadbed Template window again. The display scale controls the size of the template. When we finish the creation of the roadbed template, we can create the offset line of the alignment. It is a function highly related to the roadbed template. In the Alignment module, the Route Auxiliary Drawing tool, click the Define Offset Curve command, and select the alignment to open the Define Route Offset Curve window. In this window, you can set the route offset curve parameters by entering the width value. But we have created the roadbed template already. Click the Pick Roadbed Template button and select the cross-section template. The system will read the roadbed template's data and automatically fill in these parameters. Click the Draw Refresh button to draw offset curves. Please note, the roadbed widening only effective when the circular curve radius is equal to or less than 250 meters. The system will display the widening value when you tick the label widening box. The cross-section module also includes the side slope cross-section template. Same with the roadbed template, under the section and modeling module, in the roadbed and slope template. Click the Create Slope Template button and select the base point to open the Create Slope Template wizard. On the top left of this window, you can select the slope template types. There are 4 types of default slopes, which are fill slope, cut slope, vertical to ground, and cut fill slope. We will discuss them one by one. Below that is the slope template diagram. All the parametric editing will be reflected in this diagram. Firstly, we will talk about the fill slope. You can edit the parameter in the right part of the window. The first parameter is the slope ratio. It controls the gradient of the slope. If you enter 1.5, which means the ratio is 1 to 1.5. The positive and negative numbers of the ratio control the direction of the slope. The next parameter is the slope height range. You need to enter the minimum height and the maximum height, and separate them with a tilde. If we set the slope ratio as 1.5 and the slope height range as 4 to 6, the system will start to generate a 1 to 1.5 gradient slope. If the slope intersected the ground within the minimum height, which is 4 meters in this case, the system will stop calculating and generate the slope model. If the slope height reaches 4 meters, and the slope does not intersect with the ground, the slope will be extended to a maximum height of 6 meters. If the slope intersects with the ground, the system will stop calculating and generate the slope model. If the slope still cannot intersect the ground at the maximum height, which is 6 meters in this case, the system will generate a 1 to 1.5 gradient slope with the minimum slope height, which is 4 meters in this case, and generate a berm, and repeat the process above. Try to intersect the ground within 6 meters. Since the slope height is a range, if you want to fix the slope height to 4 meters, you need to set both the minimum and maximum slope height to 4, and separate them with a tilde. You can set different slope ratios, separating them with a semicolon. For example, if you enter 1.5 and 1.75 in the slope ratio, and the slope height is 4 to 6, the system will start by generating a 1 to 1.5 gradient slope. If this slope did not intersect the ground within 6 meters, the system will generate a 4 meter high slope and a berm. The next slope will be a 1 to 1.75 gradient slope. If the second slope still does not intersect the ground within 6 meters, the system will generate a 4 meter high slope with a 1 to 1.75 ratio and another berm. Then repeat the slope generation process with the last slope ratio, which will be 1.75 in this case. The slope height range is the same. You can set different ranges and separate them with a semicolon. If the slope ratio is 1.5 and 1.75, the slope height range is 4 to 6 and 7 to 8. The first slope will have 1 to 1.5 slope ratio, and try to intersect the ground within 6 meters. If the slope cannot find the intersection, the system will generate a 1 to 1.5 ratio, 4 meter high slope with a berm. The next one will have a 1 to 1.75 ratio, but with a 7 meter slope height. If it cannot intersect with the ground in 7 meters, it will extend to the maximum slope height, which will be 8 meters. If the slope still fails to intersect the ground, the system will generate a 7 meters high slope with 1 to 1.75 ratio. Generate another berm. and repeat to generate the next slope with the last set of parameters, which will be 1 to 1.75 slope ratio and 7 to 8 meter slope height. You can set the slope ratio and height as many as you want. But if the system calculated all the parameters you have entered, and the slope still fails to intersect the ground, the system repeats generating the slope with the last slope ratio and height. The last two parameters are the berm width, which controls the length of berms, and the berm slope ratio controls the gradient of the berm. Similar to the slope ratio, the positive and negative numbers control the direction. There is an angle between the berm and the slope. You can set it as an arc by ticking the arc slope radius box and setting the radius. The next template is the cut slope. The calculation method of the slope ratio and the slope height range is similar to the fill slope, but the direction of the slope is opposite. The major difference is that the cut slope contains a side ditch. You can set and edit the ditch parameter under the cut slope ditch options. Here you can set different ditch types and edit the bottom width and depth. The third slope type is vertical to the ground. If two roads are close to each other, and one road has a slope already, the other road's side slope will be set at a vertical angle to avoid conflicts. Lastly, the cut-fill slope is designed for a special situation. When the ground line is close to and above the pavement, neither the fill slope can intersect with the ground line, nor the cut slope, due to the existence of the side ditch. You can use the cut-fill slope method so that the slope can intersect with the ground. When you finish setting up the slope template parameters, click Create to generate the slope template. Finally, we will discuss the ditch template. Same with the roadbed and the slope template. In the roadbed template and slope template tool, under the section and modeling module, select the Create Ditch Template command. Click anywhere to set the base point, and the Edit Ditch template will be opened. EICAD has two ditch template types: side ditch and intercepting ditch. The side ditch refers to the outside ditch of the fill slope, and the intercepting ditch is located at the top of the cut slope. At the top left, you can name the template and set the drawing scale. On the right side, you can edit the ditch in detail, such as the ditch shape, the label position, the width and the depth of each component. The berm ditch offset parameters controls the berm parameters, such as width and slope ratio, and intersected ground options. It controls the parameters of the slope dike, including height, width, and other relevant parameters. All the cross-section functions support import and export templates. Click the export icon at the top of the roadbed, slope, and ditch template windows, and the folder-shaped icon beside the export icon is used to import cross-section files. You can export cross-section files as a .xml file. This file can be opened and edited in the project data environment. You can export and save the commonly used cross-section templates and import it to the needed project. In this episode, we discussed the creation and modification of different cross-sections, which includes the roadbed template, the slope template, and the ditch template. In the next episode, we will discuss the assembly design, which is the combination and application of the route alignment, profile, super elevation, and cross-sections.